let's say you have a function which can't be integrated algebraically. How do you then go about working out the area under the curve? So let's say you had something like this. Okay. This function, y equals fx, can't be solved algebraically. I'm just making that up. It can't, right? Now, in order to find the area under the curve, what you can do is you can split a portion of this curve. Let's say we have the intervals a to b. We can split up a to b into multiple shapes. So something like this. Okay? And you're going to then connect, or you can then connect each dotted line. So if I do that, if I connected this with this, and like that, the connections, the connect the dot lines, follow the curve relatively closely. The shape that I have is a trapezium. Okay, so each of these red blocks would be a trapezium. If I work out the area of every single trapezium and I add it together, I then have an estimate for the area under the curve. I hope that made sense. So, this whole process is known as the Trapezium Rule. And there is a formula for the Trapezium Rule. The Trapezium Rule looks like this. If you have a function between a and b with respect to x, this is going to be approximately, and that's what those two squiggle lines are, a half of h y0 plus 2 times y1 plus y2 plus y3 all the way to yn minus 1 and then plus yn close bracket. Okay, what's all this y stuff? So y0 would be this line there. y1 would be that line. y2 would be this line. y3, y4, y5, so on and so forth. The h would be the width of the trapezium. So this would be h. That would be the h. Okay? In order to work out h, you would do b minus a over n, where n is the number of trapeziums. Okay, if you're lost right now, don't worry, I'm going to go through an example, it's going to make sense. This one. So, you've been given the function y equals sec x. You've got a drawing of the curve, and you know that you're trying to find the area between 0 and pi over 3. Now, in the trapezium rule, you will pretty much always have a table of x values and then the subsequent y values. In order to work out the y values, you just substitute the x. So substituting x equals 0 into y equals sec x would give y equals 1. If you plugged in x equals pi over 12, you would get 1.035 because y is going to be the same as sec pi over 12, which is 1 over cos pi over 12. That's 1.035 to 4 significant figures. And usually, when we're doing the trapezium rule, you want your y to 4 significant figures. Okay, so if you plugged in pi over 6 and pi over 4, what would you get? This would be 1.155. This would be 1.414. Cool. Now we're ready to use the trapezium rule. Your h you work out by doing b minus a all over n. So your b is pi over 3. Let me rewrite that 3. Minus a, which is 0, all over n, the number of trapeziums. Here's how I figure out how many trapeziums there are. I take this line, that means trapezium 1. This would be trapezium 2. This would be trapezium 3. That would be trapezium 4. So in this case, there are 4 trapeziums. So over 4, which is the same as pi over 12. Okay, so you've got h. Now, the trapezium rule, I'm going to copy from here. And I'm going to paste it there. Okay, so we're going to start off with a half times pi over 12. And then we're going to use a square bracket. Now, y0 is the first y value. This one. So, 1 plus 2 times. And then you're going to do every single or every middle y value. By that I mean, this is the first value, this is the last value. These are the middle values. That's what goes inside your brackets when you have the 2 and then the open bracket. So, you've got 1.035 plus 1.155 plus 1.414. Okay, and then the last one. Cool. Now, just got to stick that in the calculator. After sticking that in the calculator, you have approximately 1.34 to 2 decimal place. That's your answer. Done. Trapezium rule. It's as easy as that. You just need to identify your terms. You need to figure out h, you need to figure out all the y values, plug it in, stick it in the calculator, good to go. Okay, part C. Explain with reason whether your estimate will be an underestimate or an overestimate. Okay, let's refer to this diagram. We have 4 trapeziums in total. 1, 2, 3, 4. Okay? If I connect them, like this. Let me redo that actually. And let me get a bit closer. Let's do it like that. I think this is as close as I can get. Okay. Now if I connect them, I get this. I know it's hard to tell, but do you see how there's like a little tiny gap in between my trapeziums and the actual graph, right? That gap means I have extra area. I've worked out more than I need to. Therefore, this value of 1.34 would be an overestimate. Okay? Because the graph is convex, connections are above the curve. Okay? Let's say if it was the other way around. Let's say if our curve went this way and these were your trapeziums and you connected them, other way around, like this. This is our graph. And you do that. And now when you connect them, you are slightly, ever so slightly, under every time. So you have an underestimate. You haven't worked out as much as there is. I hope that made sense. I know that's confusing. If your trapeziums, the connections, are above the graph, even slightly, you have an overestimate. If your connections of each trapezia are under the graph, you have an underestimate. There you go. That is the trapezium rule. Every time you have a question, you will get a table. I think I'm yet to see a question where you don't have a table already given. At most, if they're being really, really nasty, they will expect you to draw your own table. But there's no way to do it without. Always use a table. After you've done enough questions, the trapezium rule will come more second nature. You won't have to write it down every time. And then, yeah, you're good. There you go. Trapezium rule.